Today I'm very excited. Yeah, this is me being excited. Yeah! That we get to do waves now. And you get to come into my house. That's my kitchen. I did this floor. This is my daughter Taylor. My son Toby's in witness protection, would prefer not to be on video. So they're going to demonstrate for you two different types of waves. Taylor, can you demonstrate a transverse wave? Give me a series of transverse waves. Just keep on going them. Keep on sending them. Okay. So as she's sending, you can see her moving her arms back and forth. Those waves are moving all the way down to Toby. Thing is, the medium is going back and forth. Okay, Tay, stop. Send one single wave all the way down. No, let Toby wait. Okay, do that again. Okay, you see how the medium moves to the side, but the wave is moving straight along the slinky. But it pushes the medium to the side. Toby, can you demonstrate a longitudinal wave? Whoa, do that again. Give me a series of those now. Okay. Now, as Toby's making longitudinal waves, those series of compressions are going in the same direction as that slinky. Next thing we're going to do is, what are we going to do? So, Taylor, show me transverse wave with a little tiny amplitude. Okay, and make the amplitude a little bigger now. Okay, let's look at her while she does that. Now make it even bigger. Okay, make it even bigger. Make it even bigger. Okay, how are you making those bigger waves?
Well, I'm moving them farther. I'm moving myself farther. It's not really a matter of force. I'm just moving it farther.
Okay, so you're using the same force, but you're using over a greater distance. All right. That sounds interesting. So what I want you guys to do now is Toby is going to send a bunch of transverse waves to Taylor, but look at this, this ruler. Every time there's 10 centimeters goes by, it changes colors. I need you guys to estimate the wavelength by counting the spacing between two wave pulses. So Toby, send a few wave pulses down there, transverse waves. Try to send one at a time then. Okay, Taylor, you send yours. Send it on the other side, so it's closer to the ruler. There we go. Nice. Okay, guys. That should be enough for them to calculate the wavelength, the distance between two waves. Okay, now I want you guys to see if you can make, let's do this one at a time. Taylor, try to make, give me those wave pulses, just a series of transverse waves. Okay, keep on going with a series of transverse waves. Okay, now I want you to try to make the wavelength smaller. Make those waves closer together. How can we do that? Okay, let's see. Toby, why don't you try? Try to make transverse waves smaller. The wavelength smaller. It's not working so well. Yeah, go back and forth really quick, but don't change the amplitude. Don't change the amplitude, but go back really quickly, back and forth. Just one person. Okay, go ahead, Taylor. Send it slow first. Slow. See those long waves? Now make it fast. See, now we're seeing more shorter wavelengths. Okay. All right, let's keep on. That's good for now. All right. Now we're looking at frequency of waves. Toby, I want you to try to make a wave with a frequency of 1 wave per second. Meaning every second goes by, a new wave comes. I'm going to count out the seconds as they go by. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. Toby, how many times are you making a wave when I'm counting every second? One wave every second you're generating, okay, to get a frequency of 1 wave per second. Okay. Taylor, I want you to make a smaller frequency. So I need less cycles per second. And I'm going to count out the seconds, okay? All right, ready? 1, 2, 3, 4. Seems like you're doing 1 cycle every second. I want less frequency. Okay, I'm still going to count out the seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how are you making these shorter? Less frequency.
Well, it seems like the faster you do it, the bigger they are. But I'm using a rate to measure. But if I do it slowly, it's not really that big.
Yeah, now Toby did a complete cycle every second. And then when you went to a smaller frequency, looks like you did half a cycle every second. And that would lower the frequency, right? Because then you would only get half a wave every second. All right, cool. So I'm asking you guys to, not you guys, but you guys. Ooh, that's ugly. You want to state the relationship between wavelength and frequency. So Taylor, show me a small frequency and then a bigger frequency. Toby, try the same thing. Small frequency, and now a big frequency. Okay, now that's amplitude. You gave me a bigger amplitude. I want a bigger frequency. Yes, that's a high frequency. Okay, I'm not going to get your face in it, but go ahead, make a high frequency. Okay. All right, cool. Taylor, make a low frequency, and then I want to now focus on that wavelength. Is that a big wavelength or a small wavelength when you have a small frequency? Now look how far apart the wave crests are. Yeah, so at a small frequency we have a high, big wavelength. Now make a big frequency. Yeah, look how close those are together now. Okay, so the higher the frequency, the smaller the wavelength. Okay, now we're going to look at the velocity of the waves, and this is going to be tough. So you guys, you're going to have to pause the video when we send these waves. Toby's going to send some longitudinal waves, just one at a time. And look, I've got 2 meter sticks across there. I forgot to put a timer there, but you can use the timer on the video. So go ahead, Toby, send a longitudinal wave. Okay, that's 2 meters, remember. Go ahead, send another one. Okay, so try to get, I'm going to give you the best estimate, okay? So you should be able to have a good answer here. One more time. Okay, Taylor, send a transverse wave. No, never mind, hold on. That might confuse things. All right, let's go to the next thing. All right, so now what we're going to do is we're going to change the tension in the waves. So hold on, guys. I'm going to take this and I'm going to stretch this out. Okay, now it's really